Good evening, junior engineers, technicians, scientists, junior doctors, and professors in different areas in engineering and technology. Now, we want to examine WAEC 2025 Physics Practical Trial Questions. 1. Mechanics. This is the diagram of the question. This is a retort stand, this one and this. These are the two retort stands. This is the meter rule, first meter rule, second meter rule. This is mass M. These are 120 centimeter thread, 1 and 2. This is the table on which you place it. These are the tables. Now, you are provided with two 1 meter rules, two retort stands, 120 centimeter thread times 2, mass label M, knife edge, and other necessary apparatus. 2. Place one of the rules on the knife edge and determine its center of gravity C. Mark this position with a marker. Read and record the mass MR of the meter rule written on the reverse side of it. 4. Attach the mass M firmly to the meter rule AB at C using sellotape. This is sellotape. 5. Suspend meter rule by two parallel threads of length 40 cm at the 10 cm and 90 cm marks. Ensure that the graduated face of the meter rule is facing upwards. Set the meter rule AB into a small angular oscillation about the vertical axis through its center of gravity. 7. Determine the time t of 20 complete oscillation. Evaluate time t, period t, and t squared. Read and record. 8. Read and record the value of D in meter. 9. Keeping the D constant throughout the experiment. Repeat the procedure for other values of H is equal to 50, H is equal to 50, 60, 70, and 80 centimeter. In each case, determine the corresponding values of T, capital T, that is period, and T squared. Tabulate your readings. Plot a graph of T squared on the vertical axis and H on the horizontal axis. Determine the slopes of the graph. State two precautions taken to ensure accurate results. Define the number B1. Define the time couple as it relates to rotational oscillatory system. B2. Give two practical applications of couple in everyday life. As you can see, this present practical, you see the complex physical appearance or nature of the practical. This particular practical, we train the learners holistically, and it will increase their ability to gain emotional intelligence, social intelligence, adversity. In addition to adversity intelligence, in addition to intelligence quotient, which most of the written work give the learners. Now, let us start. This is the meter rule. I've measured it, and it is a 130 gram. 130 gram. The center of center of gravity is center of gravity is 50 centimeter. Now, D, the distance between them, the distance D in between them is 100 centimeter. The total length of the 1 meter rule is 100 centimeter. So when you remove 10 plus 10, that is 20. 20 from 100, you have D to be 80 centimeter. D is 80 centimeter. Now, we want to start. This is my stopwatch. As I displace this is length, 40 centimeter length. You are going to start with 40 centimeter length. When you measure it from here, from the top of the meter rule to this place is 40 centimeter. This one is also 40 centimeter. Now, as I displace it in rotational direction, in circular direction, at the same time, when I start, I will start the stop clock at the same time. Then I will watch the time for 20 oscillations. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation for the first one is 20 seconds. I will repeat it again. Close that window a little bit. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21.00 seconds. Now, the next one is height 50 centimeter. Height 50 centimeter. This is height h of 50 centimeter. I will also displace it and record the time for 20 oscillations. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation is 24 for 50. For the second one, one, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This time around is 25. Now let's look at 50 and 60 height 60. This is 60 on this side. This is another 60 on the second side. Watch it. So we want to start . Now, for 60, we want to start the displacement. 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This time around is 26. Then again, I repeat it for the second time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 27. Now we're now going to 70. At 70. This is 70. This is 70. At 70. Now I want to start again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 28. For the second one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30. Then the final length is 80 centimeter. This is 80. Sílé. Now, this is the last 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 32. Now, having done that, we now want to find the average time taken for the 20 oscillation by adding T1 and T2 and divide it by 2. 20 plus 21 is 41. 41 divided by 2 is 20.50. 24 plus 25 divided is 49. 49 divided by 2 is 24.50. 26 plus 27 is 53. 53 divided by 2 is 26.50. 28 plus 30 is 58. 58 divided by 2 is 29. 29.00. Then 30 plus 32 is equal to 62. 62 divided by 2 is 31.00. Now, after that, we are now going to pause it. Now, 20.50 times 20.50 is equal to 420.25. Sorry. No, sorry. First, we are going to divide TA by 20 to get the period. So 20.5 divided by 20. 20.5 divided by 20. 1.025. 24.5 divided by 20. 1.225. 26.5 divided by 20. 1.325. 29 divided by 20. 1.450. 31 divided by is equal to 1.550. Now, to get T square, I'm going to square this one. 1.025 times 1.025 is equal to 1.051. 1.051. 1.225 times 1.225 is equal to 1.501. 1.501. Then 1.325 square, 1.325 times 1.325, 1.325 times 1.325 is equal to 1.756. 1.756. Then 1.5 square, 1.45 square, 0.45 times 1.45 is equal to 2.103. 1.55 times 1.55 is equal to 2.403. 2.403. Now, the next thing, we've calculated the readings. The next thing is to plot the graph of t squared against h. I want to start plotting the graph of t squared against h. First of all, you draw the vertical axis. Then you start from 0, 0.0. The maximum value here is 2.4 and the minimum value is 1.05. So as a result of that, we are going to use 0.5 to represent 10 small square. 0.5, 1, 1.5, 2.5. What we are going to use 0.5 to represent 20 small square. So this is 0.0, 0.5, 1.0, 1.5, 2.0, 2.5. That is t squared. Now, the maximum value, minimum value on the under h is 40 and the maximum is 80. So we are going to use 10 small square to represent 10 centimeter or 1 unit. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, you can now start. When h is equal to 40 centimeter, t squared is equal to 1.05. When you want to plot, in plotting, we plot to 2 decimal places. So we are going to plot 40 against 1.25, 50 against 1.54, 60 against 1.76, 70 against 2.10, and 80 against 2.40. So 40, this is 40 centimeter. T square is 1.05. This is 1, so 1.05 will be here. 50 against 1.50. This is 50. This is 1.50. Then 60 against 1.76. This is 60. This is 1.5. This is 1.5. This is 1.75. 1.75 will be here. So 1.76 will be about 2 square above 1.75. So 70 is against 2.10. 70 is 70. This is 2.0. So 2.10 will be 2 centimeter, 2 small square above 2.0. Now 80 against 2.40. This is 80. We trace it to 2.4. This is 2.0. This is 2.25. 2.40 will be here. This is 2.225. 20 divided by 0.5. I mean 0.5 divided by 20. 0.025. So this will be 2.25, 2.3, 2.3, 2.35, 2.4. 2.4 will be here. Under 80. So after that, we are going to draw a straight horizontal, a straight line joining minimum of 3 points, and others will be evenly distributed. So that is the line. 3 points are involved. Now, we want to calculate the slope. Before we can calculate the slope, we are going to draw a very large right angle triangle. We can select this point. This is a large right angle triangle. So this will be y2, this will be y1, this will be x2, this will be x1. Now our y2 is 2.40. Our y1 is you trace it from here to this point. For y2, you trace it from here up to this point. Then this one from here to y-axis, that is 0.5 divided by our x2 is 80. Our x1, we trace it to the vertical horizontal axis. This is 19.9, approximately 20.0. This one will give us 0, 4 minus 5, 14 minus 5, 9. 1.9, 80 minus 20, 60. 1.9 divided by 60 will give us 1.90 divided by 60 is equal to 1.9 divided by 60 is equal to 0.032. Slope is 0.032 second square per centimeter. Now, the next thing to determine the slope, we are directed to state 2 precautions taken to ensure accurate results. First precaution is that we avoided a windy environment. Not only that, we noted and corrected 0 error on the meter rule. We can choose avoided parallax error or meter rule. Now, the next one is B1. Define the time couple as it relates to rotational oscillatory system. A couple is two equal but oppositely directed parallel forces rotating about a fixed point. Then D2. Give 2 practical applications of couple in everyday life. 2 practical applications of a couple in everyday life are turning tap for releasing treated water and turning the steering of a vehicle, either car, buses, or whatever. Thank you very much.